Good morning, students. So today I am going to teach you types of friction. Types of friction. Actually, there are three types: static friction, and kinetic friction, and rolling friction. These are the three types of frictions. Okay. Actually, first one is a static friction. Static friction. Suppose a block is on rough horizontal surface. A block is on just a block is at rest. A block is at rest on a rough horizontal surface. Okay. Now, what are the forces acting on the block? Here, what are the forces on the block? Here, the block weight. Here, block weight mg acting vertically downwards, and a normal reaction is acting vertically upwards. And here, a block is on rough horizontal surface. A block is on rough surface. Weight of the block always acting vertically down, and this surface exert a normal reaction on block upwards. So here normal reaction is equal to weight of the block mg. Here normal reaction n is equal to mg was. Here normal reaction equal to mg. Okay. Now what is static friction? Whenever block is at rest, when block is at rest, the frictional force between contacting surfaces. When block is at rest on the ground, the friction between the block and this contacting surface, okay, and ground is called static friction. Whenever block is at rest, on the ground, the frictional force between the block and this ground is called static friction. Actually, static friction representation is F suffix S, Fs, not Fs, F suffix S. It is a representation of static friction. Okay, boss? Actually, whenever block is on ground, the frictional force present between block and ground is called static frictional force. Okay. Now here no force is applied. Here no force. When force applied on the body to move is zero. When force is applied on the block to move, okay, is zero. Here no meaning of static friction. When block is at rest on the ground, here static friction is there is no static friction. When block is on the ground, for example, a book is on table. Now what is the static friction between a book and table? It is zero. Okay, and without any applied force, to move the block, if applied force equal to zero, we are not applying any force. Here there is no meaning of static friction. Okay, applied force lekapothe, okay, if there is no applied force on this block, there is no friction is developed, and there is no friction between the body and ground. Okay, so applied force on the body is equal to zero. When applied force equal to zero, here no friction between contacting surfaces. So static friction is equal to static friction. The static friction is equal to zero was. Okay, and a force apply చేయకపోతే ఇక్కడ friction ఏమి develop అవ్వదు. Okay, whenever the force is applied, then only friction is developed here. Otherwise, there is no static friction. Block rest లో ఉంటే static friction develop అవ్వదు. Okay, applied force apply చేస్తేనే, whenever the force applied to move the block, then only static friction is present here. Okay, so when applied force on the body is zero, then what is static friction between the block and ground? It is also zero. There is no friction. Okay, now a very small force is applied on the block. A very small force applied on the block for motion of the block. And a very small force applied, but still block is at rest. And when a small force applied, still the block is at rest. Okay, boss? Now, the static friction is present opposite to applied force with equal magnitude. Okay? Whenever the applied force, when a small force applied on the block, then only this block is at rest. By applying this force also, block is at rest. Now, a friction is present. A static friction is present between block and ground opposite to applied force but with equal magnitude. Equal means if applied force is 1 Newton, it is 1 Newton. Here also the static friction present is 1 Newton. Okay, boss? If applied force is all increases gradually, if applied force value is increases gradually, but first we are applying 1 Newton, next we are applying 2 Newton, next we are applying 3 Newton, okay? Then static friction is also increases same value. If applied force is 1 Newton, static friction is 1 Newton. If applied force is 2 Newtons, the static friction also 2 Newtons. If applied force is 3 Newton, static friction is also 3 Newtons. Okay? If applied force is 1 Newton, 2 Newton, 3 Newtons, then static friction is also present equal in magnitude until the block is moving. This is very important. Until the block start motion, until the block is moving, applied force will be equal to static frictional force. Okay? Until the block start moving, applied force equal to static frictional force. And so applied force applied is always equal to static frictional force. Remember this point, it's a very important point. Okay? Until the block is moving. Until the block moving means block is at rest, and still block is at rest. Okay? And the block rest lo unte, whatever the applied force is here, the same value of friction is developed opposite to applied force. Okay? So applied force is always equal to static frictional force. Applied force equal to static frictional force. Okay? That is the reason why this static friction is called self-adjusting force. This static friction is called self-adjusting, and a self-adjusting force. Self-adjusting force. And this is the reason why static friction is called self-adjusting. Until the block is moving, applied force will be same as static friction. Okay? If a further increase in applied force, then the block is ready to slide. By increasing force up to some extent, this block is ready to slide. This block is ready to move or ready to slide. Now, the static friction reaches to whenever the block is ready to move up to 3 Newtons, block is still at rest. When force applied is 4 Newton, this block is ready to slide. When this block is ready to start the motion. Okay, now this static friction reaches to a peak value. When the static friction reaches to a peak value, that the peak or maximum value, that maximum static friction is called limiting friction. Okay, and until the block is moving, until the block start the motion, applied force will be equal to static frictional force. When block is ready to slide, once the block ready to slide, the maximum static friction is present. The maximum static friction is present. That maximum static friction is called limiting friction. That is called limiting friction. Okay. Here, limiting friction is directly proportional to normal reaction. Limiting friction directly proportional to normal reaction. Okay. Therefore, limiting friction is equal to some constant. After proportionality, there is a constant. That constant value is mu s into n. Mu s into n. Here, what is n value? Here, n value is equal to mg. Okay. But actually, here important point is until the block is start moving, applied force will be always equal to static frictional force. That's why it is called self-adjusting force. Okay. Here, static friction is independent of normal reaction. But once the body start the motion, once the body ready to start the motion, here static friction reaches a peak value or maximum value. That maximum static friction is called limiting friction. That is called limiting friction. Here, limiting friction is directly proportional to normal reaction. Okay, boss? Therefore, limiting friction is equal to, after proportionality, there is a constant. This constant mu s is called coefficient of static friction. Mu s is called coefficient. The coefficient of static friction. Coefficient of static friction. Therefore, the formula of limiting friction is equal to the coefficient of static friction into normal reaction. Here only there is one point. Until the block is start moving, applied force equal to static friction. Okay, when block is ready to slide, here static friction reaches to peak value or maximum value. That maximum static friction is called limiting friction. Okay, the maximum static friction is called limiting. Block rest lo unte friction untundi static friction. Block just ready to move, ready to slide. Okay, now the maximum static friction is called limiting friction. The limiting friction proportional to normal reaction. After proportionality, there is a constant. That constant is called coefficient of static friction. Okay, boss? Here one more important point. What is the minimum force required to start the motion? Then start cheyalante and force apply cheyali. What is the minimum force? What is the minimum force required to start the motion? Okay. And the minimum force required to start the motion is limiting friction. Okay. If you apply this much force, the force equal to limiting friction, then block is ready to slide. Okay. So minimum force needed to move the block is that must be equal to limiting frictional force. Block ni move cheyalante applied force ఎంత ఉండాలి? Block ni move చేయడం కాదు, start చేయాలి. Ready to move, just begin to move. And ఈ బ్లాక్ ని మూవ్ చేయాలంటే అప్లైడ్ ఫోర్స్ ఎంత ఉండాలి? దట్ అప్లైడ్ ఫోర్స్ మినిమం ఎంత ఉండాలి? మినిమం, నాట్ మాక్సిమం. మినిమం ఎంత ఉండాలి? దట్ ఫోర్స్ షుడ్ బి ఈక్వల్ టు limiting friction. That should be equal to limiting friction. Okay, boss?